Check, check. Check, check. Ooh, nice. Welcome to the chat room, okay? We can pop that out. Pop you down. Lovely. Welcome to Amber Skies. We have everything we need, I think. We'll see. We'll see. Let's grab the coffee. Let's wake up a little bit. Now, let's think. I've added a program. Putty. SSH. My, it's been a long time since I've used this kind of thing. So we're looking at what? 192.168.0.100. There's your basics. Okay. Whatever. Colours. Oh my god, it's got colours now. Okay. What happens if I press open? It says login as Blades. And it asks me for a password. What have we got? We've got documentation, system information. It's a Ubuntu 20.04.3 LTS. Have we got anything on this server? No. Cool. Look at that, we've got a server. This is a real server. Not just a fake one. It's the Amber Sky server. I've just had it wiped. So we are going to need a directory. We're going to call that storage. We're also going to need a directory for service. There we go. Service and storage now exist. Storage we're going to fill up, but not from here. Okay. Right, things are working. That's unusual for me, isn't it? My life deals with things that aren't working, not with things that do work. I'm just waiting for another machine to boot up. It's probably already booted up, but I don't care. We'll wait a bit longer. So what's this for? Well, this standalone server was this is the old Amber Sky server, the one that was running the Amber Skies network, which has been now dismantled as I'm retiring. Now there's a lot of things that are missing now because this is a completely fresh server as of about 30 minutes ago. So it is as blank can be. Okay, the other machine should be ready to use. Let's check through on there. I will take another window. Why did it come back to this window? I want desktop 1. Windows. Are you trying to tell me you can't do this? Thank you. Okay. I need a mouse for this machine, don't I? We have a mouse. Blah de blah de blah. No. No. I will try you. Of course. So it's 192.168, and I'm getting nothing out of this keyboard because it's the wrong computer. .168.0.100. Username is now Blades. Password is something or other. And it's port 22. There we go. So there is our service, and there is our storage. And here we have the old server. And there she blows. So these are all the data files that I've collected over time. Just a few. Only another 75,000 to go. Lovely. So that's data. There's an awful lot of data on there about different things. So we'll just do that. I think we'll wait before we can assume that. So all of my research and other stuff is on here. Let's put it that way. Only a few files. And another 68,000 to go. So this is going into storage, as this is past stuff. The service that we are going to be creating is for our new stuff. And so far, we have to make a choice now, today. Today we have to make the final choice on what kind of server we want to build. As we've got all the pieces now, haven't we? And yes, this is a real server that I'm using. Just installed it with the Ubuntu server. Just something basic, something that's usable. So it's lightweight and won't bother me too much. In other words, I won't need to do anything to it much. I just wanted something quick and easy that I could throw onto it. So I downloaded the server, Ubuntu server, put it onto a pen drive, put the pen drive into the standalone server and booted it. Followed the instructions, and there you go. Not a difficult process. If you are doing this for yourself and you are on Windows, I would advise trying this little baby here. It's called the Universal USB Installer, pendrivelinux.com. Alright, try that. That'll get you USB. It comes in this little lightweight executable file which you can just dump anywhere. I found it makes the least errors. Yes, Windows is that good. Making a pen drive on Windows is a nightmare. This, what we're looking at here, is just a capture card, if you really wanted to know. I was going to use it for streaming. Don't need to. It's better off in it as its usage here. Just adding an extra machine for us. Alright, so we'll come back to you, shall we? We'll come back to Sandbox if we need to. I think we do, because that's the other choice that we've got today. What? A failed sign-in works. That'll do. That's good. Security, isn't it? We do have changes. What are the changes? Okay. So having this problem here, hello turned out to be that. I've got a damn good idea why, but it's not the point. It is certainly not the point of this exercise, shall we say. How are we doing? $37,000 to go. So let's what else could we do with this data to make it work? Well, I've got a feeling nothing. I think that is the correct answer. Programmatically, we can do quite a few things. Woo! Okay. Fine. I don't like this uint 8, as you've already determined from last week. I think it's a bad choice. That's legal, but it's not maybe what I want. Let's change this data. Let's go for individual characters. So it's H. E. L. Complicated stuff here. L. And O. Right. That is an interesting way of putting data into a character array. Can we place that character array across here? It is looking for a uint 8. Which is an address. And data itself is the address, the memory address of where these have been placed in memory. Theoretically, that should work. Okay, let's just try a rebuild on our client. So local client, do a rebuild. It succeeded with no warnings. Hold on a minute. Shouldn't have there been warnings? The answer is no. Because it's a memory address being passed over to another memory address. Does it hold the correct information? Possibly. Would that work? Or will it give us that result again? This is the question, or will it just fail completely? Which we have had so far in the past. Right, you think about that for a second. Whilst I get my storage sorted out. So anybody that's been following the stream knows that I am very, very unhappy about how this program is working. And how it should work. Now the fault doesn't lie in the program. unfortunately. The problem lies in the way the SDL network manages the data for UDP, which is the Universal Datagram Protocol. So we may have to have a little bit more of an in-depth delve into this if we want to use it. Do I want to use it? I'm not bothered. I've never successfully managed to get SDL2 to work on networking with UDP. So this is a little bit of a personal let's have a go type thing. Only 5,000 files to go. So what was that message? Virus threat. Didn't know we had one. Is there a virus threat going on? Really? It's funny, in my lifetime, over the course of the last 25 years, I've had 2 viruses, both of which I sent back to the people who sent them. Kind of thing I don't mind. No, would like to close this connection as well before we move on. Transfer's finished. Thank you. No failed transfers. Nah, there's no failed transfers. Okay, disconnected. Goodbye. And goodbye to you for now. But thank you. Let's go back onto my other side. Right, let's have a look at this. Oh, first of all, click in here. If we change the directory to storage, and we can now do that. There you go. Everything's there. Isn't that nice? Good system. Alrighty. Onwards and downwards, because this is probably not going to work. Oh, thank you, valid. Or, okay, we'll call you valid user. Thank you for the follow. Very kind. What should we do? Shall we just run it? Hey, beep bop to you too. Let's get this running. We'll need a server for this. So, Visual Studio, we've got a server on here, haven't we? Okay, server. Set a startup project, and let's just run it. C#3. Oh, yeah. I'd never thought of that. Thank you. That's a very good point. So here's our little UDP local server. Doesn't do much. We'll just pop it over here. Let's try running our client. Damn you, UDP, you just worked. So we have a UDP client. Updated. This is probably going to break. Works why? Why does this work? It's because I'm not trying to make a string out of it. Last week I was trying to make a string out of our data. Now strings in C are handled very, very differently to individual characters. And that's why it didn't work. They're not stored the same within the system. And I also don't think we've got much to do with strings in here. If I look in the client's common file, oh, we did put it in. But it shouldn't be strings, should it? We're writing in C. Oh, no, that's okay, string header file. Whew. Nearly had a heart attack then. I did do it right. Good. So our standard libraries, they should have picked up on that. And the errors that we were getting were slightly not the right errors to guide us. It was telling me that things weren't quite okay, but we can carry on. But that's the answer, is that one. So this is stored in ASCII codes. And we are printing out ASCII codes. But, have a look on the other side a minute. Let's have a look at that server. Go to you. And it has closed. Okay, everything's closed. I hope it's closed. Yeah, everything's closed. Right, the server is printing out a string. And that's why it was bothering me. Do you see the inconsistencies that are going on here? So we make a buffer for the data incoming. We receive it through the AmberNet receive data special that's in our game lib. And yeah, we then print it out as a string. And I've also done something really weird here. Yeah. How is this possible? It's all to do with the way that strings are dealt with on the sending side, not on the receiving side. The receiving side can actually cope with it because we are placing it and creating it into a string rather than trying to take the data out of a string. And that's why all of this works. Is it correct? I'm on the fence about that. Is this line here correct? Well, this... correct. Why do I need that? That states that I'm taking the address of data incoming place 0 or index 0. No, I haven't passed anything yet. It's going to be interesting when you see the answers that are going to come through this. That can be replaced by that, because that is the address of index 0. I'm just looking for readability at the moment. C is easy. Look at it. This is the whole program. And we can get rid of that now, because it does not exist, I hope. I hope we're never going to come across that again. We'll start sorting this out into a real program. Yeah, that looks good. I tend to write downwards, so let's do that. I would change that to that. I do it just to make it more readable, really, for people. There we go. That's more readable. Yeah, the gist of it is quite simple. We initialize a network. No, we initialize SDL. We then take AmberNet and initialize that, which is the UDP network that we're using. This takes the host IP address, the port in, the port out. The port out can be null. We then say, welcome to the server, obviously. Is running. While it is running, do the following. We set up a buffer, a data incoming buffer, as characters. We don't know how big it is, so we don't give it a size. The data incoming we then receive from our little gamelib files, and we just print it. If it isn't null, just make it readable. There you go. So if it's not if the data incoming is not equal to whatever we had here, then we should be fine. And why isn't null working? It's in C. Null is working. But we can't put it. Okay, fair enough. Yeah, update. Loop used in Unity programs. Yeah, exactly. Exactly. It's actually it's the same code. It's just I'm writing it in full. You'll see every other language being written here, because every other language is basically written in C. So we print it out and we turn it to is running is false, so we can end the program. We're not stuck inside an infinite loop, and we just put a delay in to keep my processor alive and overheat, and then we just quit out of the AmberNet and the SDL. Very, very simple program. Just test. It's a test program. Basically, we just got a test program running, and it works awkwardly. And how many files is it? 2 files. I think this is a good test program. How do we put this onto this server? It's a standalone server, which was created this morning for me. So we're going to need the files. Now, there's already a couple of things I don't like about this. We are using .c as our files. But I did say I was going to write it in C. I usually write it in a CPP file, which is a C++ file, so it gets some added benefits from C++. They're not needed, absolutely, it's just creature comforts for me, because I'm not a programmer. And, well, and it won't work because we have you here. Alright, these are my final programs. Let's get them written out. So clean, project, doesn't clean. I've got to do each one individually. Clean, clean. I was going to get a bit of a ball ache. Clean. And this is... Oopsie daisy, just dropped everything. Base working code, and that is fully tested and working. If I could write. Base working code tested. Commit. Syncing. All saved. Now, we're not allowed to write any more to the master. To do so would destroy our base code. Oh, this is a bit of a mess. I've just made a bit of a mess. Don't worry. So we're going to have to change that now. So we'll have a new branch. And the branch name is going to be research. Don't use the master branch ever. Oh, right. Take care there, valid user. Check out branch. Blah, 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 blah. Could just create it, please. Thank you. We can put anything we want into this branch, as it won't affect our master copy anymore. And if we get things right, we can then upgrade our master copy to the new code. That's a better way of doing it rather than messing your master copy up. Plus, other people can do their own research or whatever they want to do on this code at the same time, not affecting your code. So let's go into research mode. What do we have so far? Is it any good? Yeah, it is. Actually, it's a bit better than I expected. What can we do with it? Well, I was thinking about popping it over to here today, but I've just realised we do have a library. And that means I'm going to have to think about this a little bit more. Yeah, I'll think about it a little bit more before we start on this path. Sudo shut down now. Let's just pop a password in to make it work. There you go. Okay. You're finished. Everything else is finished here, isn't it? There's nothing hiding. Windows hides things. I think we're okay. We haven't got other things running. Good. Right, let's try this again. Now, our server doesn't do much. It just receives some numbers, and it can then place those numbers or use those numbers how we wish. In this case, it was a string. We can convert it into anything we like. Now, strings are very important. So now we need to be able to manipulate strings. So that's our first contest, or our next objective. Let's get our objectives going. Where are they? Here we go. Right, there's our objectives. I'll keep this hanging around somewhere. I don't need to now. We might be taking a coffee break in a bit. Right, so this was that uint 8 that I was describing, and how it works, and why we were getting strange results initially, and that it goes from -1 to 8 to +127. Luckily, the ASCII codes for characters, or letters, and numbers is all below 127. And that's why I wanted to use characters. So we are going to need some string manipulation somehow. On the receiving end, it's easy. On the sending end, oh no, we can do it. We can do it. I'm just trying to think of an easy way of doing it. We do have I to A, but that's integer. Okay, first of all, we'll look at what we can do on the server side. So, what can we do? Let me just get this lot shifted. So, receiving data, server side. Let's imagine that we receive a string of data. What's in that data? That's our next decision. Now, we're going to keep it easy. Here we go. So I wrote this on day one, just as a thing. And we can use integers, can't we, for positions? So let's have the user ID as an integer. The string of data actually won't matter. We can use integers for everything here, can't we? We don't need floats, do we? If the surface of our game is split up into squares, then we can use integers. Wow. So, on here, it's going to be the user ID, definitely. It has to be the first piece of information. The user ID must be supplied by the server. Now the next item will be a service code. And then we can have the data. And that's how a server works. So we found out we can send numbers. We can't send floats unless we're really, really crafty. And to be quite honest with you, I think that's where most servers do fall down. They decide to send floats and then find out how difficult it is. That's a big problem. So let's start. Let's use integers. Because we know we can send integers quite easily. Or do we? Up to a point. And that's going... Is that going to cause a problem? Could do. We can only go up to the number 127. So that is a problem. Okay. So if we make our max transmission between 0 and 9, then we have some interesting ideas to go. Cup of coffee time, as we have success and we have things to think about. So, as I think about that, do I need that computer back up? Yeah, we'll have a cup of coffee and we'll get this computer running here so that I don't have to have this lying around. We'll transfer that to a different computer, I think. I'm just wondering about a file. Oh my god, there's so many ways I can do this. I'm going to go and make a cup of coffee. Be right back. it's funny. If I'm going from a string to individual numbers, it's easy. When I'm going from numbers to numbers, my mind goes, bah, what the heck? Right, so we've got UDP network working. Let's go to our next piece of source code. We will go for data. Add. Make sure it says folder. If it doesn't, click that button there. New folder. We'll just call it data for now. Or data handling. No, data. New item. We need a header file because it's a library. So the header file will say conversion. Conversion. I'll go with conversion.h. Because we might have to write some converters for our IMID if we're going to have to. This is going to be very interesting. And possibly could be a complete waste of time. There might be a better way of doing this. This is research, by the way. New item. We'll have a C file. Conversion.c. We'll write that as well. Okay, let's get these files set up. That'll do. Today's date, 19th. Oh, time flies. Hash include. There's no common, is there? Alright, so we don't need it. Fantastic. That'll do. Conversion.c. Hash include. Conversion.h. Done. Right, this is where the fun starts in programming for me, because I like doing research. So let's describe what we're thinking about here. We're converting integers to single individual numbers. And here we go, i.e. 2, 3, 4, 5 will go to 2, 3, 3, 4, 5. Alright? Because we need individual items of data to be able to send it through. At the other end, that's for transmitting. For transmitting over the network. Am I digging a hole for myself here? I don't know. And then we want to convert characters back a string of numbers back to the individual integers. i.e. split data string down convert each item into a number. I think that's basically it. Now both sides will need this, so the client and the server needs to be able to do this because we've got incoming and outgoing data from both. How simple can we make it? Can we simplify this down, or is this just a completely bad idea and we should just use letters, for instance? We can. But we still have this initial problem here. With letters, all you do is you add something to them. And then at the other end, you just minus it off. Complete waste of time doing that. If you're dealing with letters. I think it's, what is it, 60... No, it's 100 and something for ASCII. If we do it this way, we don't need to put that negativeness in. But it does mean we're not going to be sending characters. That then limits our network to numbers only. But then we have a chat channel to think about, don't we? So let's let's modify our thoughts and put them into characters. Otherwise, we're going to mess about with chat channels, aren't we? Let's put another one in. Strings to individual characters is easy for transmitting over there. And that becomes hello. And as we know, that became H. So this one is tested. E. L. Formulate your ideas in English. Never write a program in a different language. O. And that there becomes that. Do we need this? Use C command I to A. Simple. Bada boom, bada boom. Are we allowed to add strings together in C? I don't think we are. We'll need an index counter. Well, that's easy enough. So simplified the first part, and then we've only got the second part to do. Alright, I think we can run a test on the second part. Do we need a concatenation? Alright, so there's questions that are formulating now which would probably get better answers. We also need a control character to split data. Control characters. Standards are slashes, aren't they? Like that. But that's a bad one to use because the system uses it. At symbols we can't use. Hash. We can use. Maybe. That's a possibility. What's hash used for? Hash include. No, I think I'm happy with that one. For example, does C have the command I2A? Let's have a look. Two means binary. Alright, 10 means decimal. God, these are hard to do. I'm not compiling it down to hex, so we are not going down that path. Although that is an option. Alright, things are starting to come together. We're starting to look at the programming side of it now. We do have another question to ask here, which I guess is best asked on this screen. C string concatenation. There we go. No, C doesn't have concatenation. Thank you. Don't like that. There we go. Do you want to limit yourself to the type of data that can be sent, received via UDP? UDP doesn't care what the data is you are sending, provided the payload isn't bigger than 65K. Yeah, that's right. Absolutely. But we do need to have a standard format in which to send it and receive it, or we don't know what the data is. Otherwise, we can't decipher our own data. We can't just randomly send integers or characters. As how do we decipher it? You have to restrict yourself in some way, shape or form. You don't really have much of a choice, I don't think, about that. Unless you can think of some other way of doing it, then that's fine by me. I think we've got some stuff here to play around with and research into. I think I'm willing to research into this a bit better. Let's just go for the simple things first. Let's try this one. That doesn't make sense, what I'm looking at. But let's try it anyway. So we found out in our UDP client that if we put that to hello, we got rubbish data. Right, so let's double check ourselves. This is the first test. So that's our data. Pop up a server, and it should give us garbage. That builds. That builds. And that builds. Okay. Server going up. Client. Run it. And it damn well worked. That's not fair. Rebuild. One warning. Ah, this is what I wanted to look at. Oh, null import descript. I can't do anything about that. Not that I know of, anyway. Rebuild. No warnings. Should have been one. Rebuild. 0 warnings. Are you telling me now everything works perfectly? After last week, didn't. Couldn't work at all. Well, that's just saved me a lot of work. It's not, though. We'll assume it is. That gives us a lot easier a time with things. So if that works, I don't want hello, I want hello hash. So we need to do a string concatenate. And that would be this thing here. How does it work? String 1 is data. And the const char string 2 is hash. Is that all we need to do? Destination source. It does give a result. Okay. And I need to know what that result is. Okay. According to that, I don't need much. I've got a feeling that that's an error. It's not in here. Yeah. Absolutely, yeah. Ah. I want string cat, I don't want S. It's got a char star on it. Okay. Behavior, okay. Alright, we've got the standard lib. And we could do a count on it, yeah. Return value returns a copy of dest. Yeah, that's what I needed. Returns 0 on success. Returns non-zero on error. Also, on error, writes 0 to dest. Unless dest is a null pointer or dest is 0 or greater than r size max. So it does have some relative return values which can be used. I'm not looking for errors at the moment. So our first test, we will just do you. This functional variable may be unsafe. Consider using string cat s instead. How's about now? I just want a basic string cat. To display deprecation use, to disable deprecation use that, okay. Client, properties, preprocessor, edit, I don't know what it's got different options there for. Why did I pick C? There's every other language is C. There's no extra work. It's quite simple programming language. You still have to do all of this in other languages. If you think it's done for you, most of the time it isn't. And half the time it isn't, and that's why programs have bugs. Because people believe it's being done for them. Underscore CRT secure. No warnings. It's an interesting subject, actually, picking languages. There aren't any. There's only 3 languages that exist. There's BASIC, there is Assembler, and there is C. Those are the only 3 ones that actually exist. No, it does exactly the same, mate. I'm using SDL2 library. SDL2 is the same in Python as it is in C. There's no extra coding. Okay, let's try building that again. Oh look, it works. There's no difficulty in using C. I mean, look at the program. It's exactly the same in Python as it is what I've just written. You still have to do the SDL init. You still have to do the SDL network initialization. Printf is printf everywhere. String concatenation, yeah, okay, you can put a plus sign between them. Wow. That's all you get from it. That's all you get from Python. You still have to use SDL to send the data, printf, and then you still have to close down SDL net and SDL. So, use Python? Why? It does nothing for me. Oh yes, sorry, no, it does do something for me. It puts a load of garbage in there when it compiles. If it compiles. Maybe you have to run it on a server. Hold on a minute. Running a server on a server? Isn't that Irish? I don't know. Gosh, that gets complicated all of a sudden. Why not just do things the simple way? Just program in C. It's a lot easier to do. People don't think it's easy, only because they don't realize it is. Reload all. So, that's rebuilt. Quite strange, really, when you think about it. How few differences there are, and how many people shy away from C. Why? Ooh. We didn't send. That is an address. Expression must be a modifiable value. Okay. That's interesting, isn't it? So we have been told Porky somewhere. Why is that not working? Or is it working? Hold on a minute, we haven't even tested that, have we? But we're back to this 0 thingy again. So I've got a feeling the compilation from Microsoft isn't working exactly as expected. I have this horrible feeling that we're being Microsoft. What do we think? Look at that result. Hello. I'm not surprised it's not sending that garbage. We need we might have chosen a bad one. We might have chosen a bad delimiter. I think we have. Try space. I don't want a dot. This isn't working as expected, or as intended. So something's happening, it's filling up with rubbish. Let's try a totally stupid character. How's about pipe? It's got the pipe, but what's the rest of this stuff here? Okay. No warnings. Ooh. Whoops. It don't like that, and it won't run with the other. So, back to basics. It should run with that. I'm going back to hash, because hash is easier to read. Hold on a minute, does it have to be a char star? No. Okay, works. This is annoying. Well, well, well. The hash character is not shown. Nothing I really want to change there, is there? Okay. We're gonna have to use a space. That's rather interesting. This has no values in, except for that 0 on the mem set. That's interesting. So this is actually handling things differently than what's supposed to be. Unless I've forgotten something. String, IO, and lib. std lib. We'll have you in there. Okay, that's fine. That's a null descriptor. We haven't. Okay. It's standard lib, isn't it? Hash include std lib. Yeah, you. Okay, that gets it from the network. That could be the problem. I'm not getting the hash symbol. I don't know if it's sending it or not. Right, so I've possibly found the problem that we're having. Let's find out. We should get exactly the same result as we got for the other test. I'll do a full rebuild on you. And it's hung. We're showing hello hash here. We're only showing hello here. So that's why it was a standard lib. But we do have a failure. Stack around the variable data was corrupted. Oh. Dee 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 dee. That's because we didn't set it to max size, isn't it? I wonder. It's doing the correct thing now. Okay. So we've actually got a code -1 on that. That's interesting. This side works. So far it works. I'm not certain that we're getting everything, but we're going to try. Let's just get our local server back up, please. I'm putting this to an independent server, so I don't have to do this rubbish. And I can then put it into an endless loop, an infinite loop. Not the cleanest way of doing things, but it allows for a test server to be running fully. Again, we'll go for a full rebuild. We're working. We've just got something missing here, haven't we? Let's get this going properly now. New keyboard, so I got that. Okay, that's the only alteration I want on you. Done. Alterations here on the receiving side. I don't think that we're getting the hash sign. Alright, let's work on that. Let's work on that idea. Reserve character in C, yeah, that's what I'm thinking. No, I just need a character that would not be used in chat on a general basis. Well, not necessarily that either. It can be anything. We could use a dot. But then people... doesn't matter about that. It can be absolutely anything. Slash is a good one, but that way round. I declared it as a pointer in the code. What, the delimiter? Yeah. It's just the way that C works. Const char star means it's a string. That's how C represents a string. That's its type. So delimiter is the address of where the string starts, or the first character within the string. Every string is at least 2 characters long, but that's done in the background by the compiler. So the actual string would look like that if you looked in the memory, but you don't see that bit. That's not actually quite true. It would be that. That's what it would look like if you were to look at the memory in a disassembler for that character. It's why some are reserved characters, because it can mess memory up. I'm thinking a full stop is good enough. Seriously. This is all automated. This is automated, this bit, isn't it? Yeah. Okay. We're getting better data put through. Yes, we've got a hello dot and hello. So we need to know the last character that is being placed in the string. which would be character number 1, 2, 3, 4, 5, 6. Okay. Yeah, all strings are pointers in all languages. That's standard. If you didn't know that, you just learnt something. Every time you place these quotes around a string, that is placed into a memory address. The memory address is then used by the compiler. So yes, it's a memory address. Star doesn't mean... I mean, you can call it a pointer if you wish, but it's just a memory address. I don't work with pointers, I work with memory addresses. So yeah, the star represents a memory address. And it's the same in all languages, usually. So it depends on how you look at them. So that is the memory address of item 6. I'm passing that in at %C for the character. Did that update? Two warnings. Hold on a minute. See here we've got %C in format string conflicts with the argument 1 of type char star. So yeah, our printf isn't working properly. So we'll just take that off. Notice I'm rebuilding on this side and not that one. Still two warnings. C is an int. Really? Oh. What? Since when? I didn't know. Macros. Why doesn't it give me a list of the inputs and outputs? That's daft. %C, character. That's a character. What the hell is it talking about down here? Ah. I'm missing something. Char info 1 equals that's why it's a bit weird. Chars aren't stored as what I think they are. Don't even need that. Alright, so we've got standard char. Which is an int, by the way, in C. The char actually doesn't exist, but hey-ho, we call it a character. We're just a bit like that. But we're happier now. We're a lot happier. Just getting our data types correct. Alrighty. So there is a result, but it should have been a dot, and it isn't. Again, I'm very suspicious about this. I think it's working, but I don't think it's being handled properly. This is why I do research. I do research into data types that are able to be used and data types that aren't. So I do a lot of this experimentation, or have done in the past, but I've never done it with UDP. So we have to get a success before we can get a failure. Let's go to our client. Put a Z as a delimiter. Rerun server. Now we've got the server working. And crack it one. I think I know what I've done wrong. 1, 2, 3, 4, 5, 6. It's the 5th character, that's why. Damn you. Yeah, put 5. Alright, we'll put 4. These are the kind of tests that many people don't do. Right, we've got the O. Hold on a minute. What happens if it's changed to 7? Let's have a look at 7 and see if we get an error. I'm expecting an overflow here. Nothing. There's nothing there. That's why. Found it. We weren't transmitting it, is the answer. Grr. 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5. Got it. We got it. Wow. We can do it. We can now do it. That hash has to come through. We can use the hash character. It's a nice one that stands out in the programming language. That's why I was hoping we could use it. And that's your answer. So your delimiter is hash. That's caused a problem now. So we can't use that. We'll have to use something different for the length, as that is now causing us problems. Every time I want to transmit a piece of data, I've got to get the length right. Yes, you do. You have to know how much data you are sending. The length isn't the length necessarily of the buffer, but it's how much data you wish to send. That's what the length is used for. It's got nothing to do with the strings or anything like that. You're quite right, you don't need the length if you're using strings and a delimiter in normal programming, but we're not. I want to know how much data to send. In this case, it's 6 bytes. Oh, oops. Why did that happen? No idea. Oh well. So, This is 6 bytes of data to send. There you go. I'll just put that up as a note. We've got to change that. We can't limit our program to a static length of data. So by testing and by a bit of research there, and finding where a problem occurs, we can now program it. This is why I like doing research. Because I'm not a programmer, don't get me wrong. I'm a systems analyst. Or systems analyst. I look at systems for problems and solutions, or better solutions than the solutions that are presented. So we need a better solution for the length. It's an easy one, of course. Just use length. Yeah, you'll do. Oh, no, I don't want that one. Let's go for a standard library. I'm guessing string.h. To lower to upper. strlen. Yeah. That one. It's a size T though. That will convert easily into an int. Although they're not showing that here. Do I have to convert it to an int? Will the compiler do it for me? Let's find out. I'm happy with this bit. When doing research, I also tend to do this. Give myself a research box. Okay, so the current thing is working. So we'll save this out to, where is it, research? Yeah, we'll do it to research. I don't care what it puts in research. And that's now working. Because it's a push, not a sync. A long unsigned int in C++ and other languages, yeah. But that's not actually what it does. It gives a reference pointer to the data. That can be converted into other, well, whatever you need. Okay, that's been modified. We now have our first test for delimiters working. That's good. Let's do another then. Let's do another test. You see, a lot of people would just program everything as they see it should be. And then when you get to the final product, it's got a ton of bugs in because you don't quite understand what's going on behind the scenes. And that's why I do all this testing. A size T is a reference. T stands for type, so size type. It's not up to the compiler to decide whether it's an unsigned long or whatever. In other languages, they may have assigned it that way to try and help the person using it. But for me, I'm just going to go for a cut and a paste. And instead of typing that thing in, we're going to try something slightly different. Const char star string. There you go. It's actually looking for a const. So if I type in data, we've got a problem. Hopefully, it'll convert my data into a const, but it won't, will it? That's what I really want. Let's try it first without. One warning. Conversion from size T to int. Possible loss of data. So that's interesting. Let's tell the compiler we don't care. Okay, no warnings this time. I'm still a bit suspect about this part. It should be 6 is the answer, but that's a decimal. So %d for decimal. And then we'll just have length. Pretty simple stuff. And we should be able to just run that, I think. Let's do a full rebuild. Okay. 6, yeah. So it's doing what we expect it to, but is it correct? And we've got the same problem on the receiving side. From a long int to an int. It's not a long int. It's a size t. You've got to get that in your mind. A size t doesn't have a length. Size t is just a blank piece of data. How you wish to store it is up to you. That's what other languages don't give you. I can stick it in a float. And I'll get no warnings. If I change those two to float and that to an F, it's up to me what I do with it. The language doesn't tell me to do it in any certain way. I can put this to anything I want. That's the beauty of C. And also one of its curses, because people don't understand the difference between the types. You've got to be very careful which types you use. Now I know I just want an int for now, because I'm doing research. So that works. So that's a variable length data. There we go. That's you completed. We're starting to get some ticks going. Which I'm finding a little bit amazing, shall we say. I don't need to send it through to the server because I know what the answer is. So, variable length data. Now introduced. Not fully tested, so I'm not going to put that there. And we'll just send that off, shall we? Create it locally. And saved. Fantastic. What are we looking for next? Anything of interest that you've spotted now? We have data going through. We have variable length data going through. How do we get numbers into our data? There's a problem. Easy to solve, hopefully, but it is an initial problem. How can we do that? So our data is no longer just text. So let's start off with that. This is our goal. Alright, we should be able to run that, I hope. Remember, this is all experimental. I'm not saying this is the right way to do anything. I'm just trying to try and break people out of the mindset of a language that you're not in control of. You're perfectly in control of this language, and what you are actually doing is you are programming your own language. That's the idea of this. I should split this off into a separate section now. I don't really need to see that. So this is what we're looking for. Let's see if it works first of all. Should it work? No, it doesn't. Because we've still got that hash going on it. Server. Result is equals percent S, and it's data incoming. Done all our tests and we know that things are working properly. Data incoming should now be relevant. Blah de blah de blah, right. Rebuild. And run. Oh, good, it remembered where I put it this time. Damn it. No, come back to me. Thank you. Helps if I close the program. So we're now getting correct results. We're getting 1, 2, 3, 4, 5 hash, 1, 2, 3, 4, 5 hash. This is the goal that we want. Perfect. It's not bad. It's not a bad idea. How do we make that variable? So let's make an information. So take this off here. Where should we take this to? Alright, we'll make another one of these. It has to go up above, doesn't it? We have to sort our data out first before we can add the delimiter. Order matters. Very simple way of programming. We can now remove you. That was our data. Now our data is int info equals 1, 2, 3, 4, 5. So let's look this up, shall we? It's I to A is what we're after. Let's see how it works. That's ASCII to I. Where's I to A? Grief. I to A function. Let's just see how they've used it, shall we? I to A, they've put the integer in the first part, the buffer in the second part, and decimal. So this is one we saw before. Let's use that one again. Okay. Actually, just use it as is. So we want the integer, which is info. The buffer is going to be data. And decimal. You don't really need to put that in, I wouldn't have thought. Do I need to put that in? All right. That's what I think we should do. So I to A takes an int value. So I've got an int info. It takes a char star buffer. We've got a char data buffer size, which is a char star data. In fact, data is the address, so that's your star, and we've got a radix 10 for decimal. That works. And then we're having a hash put to it. Does this give us variable data, do you think? Server doesn't need changing for this one. A rebuild, please. There you go. ITOA, the POSIX name for this item, is deprecated. Instead, use the ISO C and C++ conformant name underscore ITOA. See online help for details. It does exist. I don't care if it's deprecated or not. Fair enough. It's asking me to do that. And it's happy if I do that. Let's run that. Perfect. Same result. So ITOA doesn't work. Underscore ITOA does work. My God, we're doing well here. So integers to strings, or integer to ASCII, working and confirmed. So integer to ASCII, working and tested. all of a sudden, we seem to have enough thoughts and testing done in these 3 areas to take a copy of it and drag it out to somewhere that's useful. It's not useful here. Okay, we're all synchronized. Oh, let's go back to our solution. And let's go back to this conversion thingy, where we started looking at the first initial ideas. And this is what we came up with. All of this lot. So, what's missing? Network buffer size is missing. Okay. Blah, blah, blah. GameLib. Add. New item. Just want a header file, don't I? And we'll call it common. There we go. There's our common. And from... No, I said I wanted it in there. Thank you. So from here we want to take the hash define and all of the includes out of here. And transfer those into common. And we should really do that. Like that. Now back in the header file. Is there a common here for us? I want that one. There isn't, is there? Okay, we'll add it. We will add it. Properties. Directories. Include directories. Edit. It says here project directory. So why haven't I got it? That's not working. Let's try this one. It's $. What the hell did they put the $? On here? I'm used to it being on the top line. Why have I just gone American? Where's the $? On an English keyboard? It's on the 4, not the 2. Okay. $. Project dir, close brackets. Do I need a backslash? Hope not. All configurations x64 apply. Thank you. It's now there. Why did I want to do that? Because I want to do exactly the same in here. And that will mean that in conversion C, network buffer now works. I'll give it 10 seconds to work out what the hell it's doing. Yeah. Microsoft. Why aren't you working? I can't put common here. Oh, just messing around with UDP servers at the moment. We've got a client and a server working. And Microsoft doesn't seem to like hash includes. For some reason. Network. See, network's working. And yet it's not finding this lot. What is wrong with this system? Ah, wait a minute, yeah. I suppose we are outside of a function, aren't we? That might be why. Temp. Make it a void. That'll do. Void temp. Those are the ideas that we've brought forward. Now, Microsoft doesn't know what to do with any of this. It's stuck a little bit, so we'll try and help it out. There we go. Everything works. Not a problem. So this is a code that we've tested. We've tested making data into anything we wish. giving ourselves a delimiter so we can separate data items out. And we also have a variable length of data so that we can send up to 1024 bytes of information. That can be changed at any time by going to common and just changing that number. So that's why it's nice to have this. So those are the items. How do we want to write our language now? The language we want to use. So I want to send some data. So we're going to have a buffer, and what we want to do is just add data willy-nilly into this buffer. In any way, shape or form that we choose to do it, so that the server understands. And the server will have access to the opposite end, which will also decipher all of this into the data that it needs to be able to work. We are getting close to opening up a spreadsheet, I think. We won't need this for a little second or two. Can I just close that? Thanks. I don't know. So, yeah. So far we've got a server that works perfectly nice and happily. And we've just worked out that we can do these kind of things programmatically to manipulate data into a format which we can send to the server. That's as far as we've got. We haven't made any decisions about this server yet. It's still blank. It's still not providing a service, shall we say. We might get through to that today, but we're already on 15:39. I've just realised we will run out of time today. I'm very limited. It's at this point that, unlike other languages, you can now create your own language. Now, the first thing I'm going to do is I'm going to start everything with Amber. So we're going to have a format. We're going to have a standard format. So we've got AmberNet, SDLNet. We look at the header file. So all of these were AmberNet. So everything in conversion has to come under Amber. That's your first thing. And now we can write whatever we like. So what I would say is something like, we'll just create something simple. Something like Amber, and then we can put data. Add int, for instance. And that will take in an int information, which I can't spell. Okay. And of course we want back from that a character string. Or a buffer. Something that we can use as a buffer. So it's a char star? Yeah, it's char star. Put a semicolon there. So we're going to send back a char star. A bunch of characters. So this is going to be our first. Let's do it properly. Integer. Thank you. Why not? It's our language, we can put it in full. So to write that piece of language, we just take what we've written. Helps you save it. Go to the bottom here. I do tend to write down the page, not across. Big reasons for it later on. Okay. And now we just pop in here. Take that semicolon off, it's not needed. The integer bit that we did. So that's this bit here. So all we're going to do is that. That's the basics of it. So we've already got information that goes in there. The data we need to create and then all we have to do is return data. That's it. Can't really say that's a difficult function to write because we've planned it all out, we've looked at possibilities, we've wandered through a different variations of state and getting to here. Does it work? What's my problem with this one? Isn't this a problem in C, returning pointer to data created on the stack? There is that problem, but I'm using 1024, a 1 kilobyte buffer, so it's not going to cause any problems. What you're talking about there is shallow copy versus a mem copy. And you're absolutely right. That ITOA does include a mem copy. So we should be okay, I think. Well, I think we'll be alright with that. It's not going to cause major issues down the line because we're only looking at temporary data. The data itself is going to be compiled, sent, and then just, it can fade away and do whatever the hell it likes. We could even delete it, which is probably a good idea. But it's all going to be done instantly as a set of functions, which are not going to be interrupted. So it'll be alright. As long as we don't use anything else on the stack at that time, we should not mess our data up. As long as you use clean code, you're fine. It's when you start saying, oh, I'll send the data later, then you've got a problem. You have to send your data straight away, otherwise, yeah, you're quite right, there's going to be problems. Why have we still got a greenie here? Function definition for temp not found. So what's this? Wrong is what it is. There we go. Don't ignore your green squigglies. Alright, we're clean. I'm just using temp to hold the code whilst we're writing it up. So if I was to use that, instead of, oh, let's make sure we can build it first of all. Ooh, no. Oh, now it's complaining about safety. Okay. So in GameLib, properties, preprocessor, definitions, edit. All configurations, underscore, caps lock, CRT. Now that won't give me an underscore, will it? Yes, you will. CRT, secure, no warnings. I'm not bothered about security, I'm bothered about how it's working. We'll talk about security at some time, at length. I will show you how to make your server perfectly secure. Alright, let's try again. Rebuild. 2 warnings still. We've got a conversion, yeah, warning 4172. Returning address of local variable or temporary data, which is exactly what you were saying. There's a problem. What it's called is a shallow copy. It's temporary. So it didn't have a mem copy in it, damn you. I don't like that warning. Because I already know about it. It doesn't want us to return the address, so we'll return the data. Okay. Damn it, that means we're going to have to do a copy. All you do for that, take the star off. Okay, I'll go with that. Rebuild. 3 warnings. Differs in levels of indirection from char 1024. Yeah, it does. Don't worry, I'm checking all of these warnings. Okay, we're down to 1 warning, which is SDL2. That's not my problem. Right. We do have a green squiggly. It's out of valid index range 0 to 1023. So this is stack allocated buffer data. Yeah, you're right actually. I'm just wondering whether I should allocate a full page. Stack allocation is problematic on that one. Okay, let's just go down to 1,000 bytes then. Actually, we can go down to 100 bytes for now. Okay. No, it's still got the wrong things there. I need it to update. It's IntelliSense by Microsoft. It's damned slow. Stuff it. It's not very helpful either. There's our command. Indexing into the array. Yeah, there is that. Which is why I didn't want to use it in the first place. Right, so local common. Let's see. Let's go down to our... Oh, our network buffer sizes stopped working. Yeah, there's that. So where were we doing our... We were actually doing it here, weren't we? So what we're looking to put is to replace that with that. Ah, wait a minute. Might help if we include the conversions. It's data. It's not really working very well, this, is it? Slash. Why is it not working? That's why. Data. Conversion. Just pop you in here for a sec. We've got two commons. Rename. And it's going to be amber common. Alright, I'm happy with all of that now. Just get our namings right. This will have to become client common. We don't have client common in here. What's in here? Ah. There it is. That should be in here as the first. Oh, right. There's the information. Char should be replaced by data. Not going to work, is it? I got something missing here. This is not working. Why not? Why are header files not working? I've had this problem before with this library business, that the header files don't work. can't open ambercommon.h. Why are you trying to open ambercommon.h? Because you're in... It's in here. And here. That's because I've placed ambercommon.h in the wrong place. Or is it? No, it's because I haven't got access to the top layer of GameLib. So it's a header file. We also have to copy. Are you right there, Poppy? We have to go up one level. Expected a semicolon. Where's my semicolon, miss? I'll come back to that. I'll do it on both. It's going to cause problems on both otherwise, isn't it? That's looking okay. Right, network buffer size is now working. I've got a semicolon missing on amber data, add into integer. That's the wrong file. Not happy with that. That's fine. Yeah. We can't do that. Well, we put that to a void. We add data as a character, char data, and we want the address. Data is the address. We now no longer have to return it because we are going to alter it. It's not a const. prefer doing it that way. So what we're going to do is we're going to take in the memory address of data and alter it directly. So this alters the contents of data. So we don't need a return value. Probably makes it simpler at the end of the day. Done. So this now needs info and data. It doesn't need you. And we don't need an int there. Lovely. That is an address. Yes, it is. So now our data gets changed by GameLib. We don't need it to be returned by GameLib as we are changing it directly using the address. So the contents of data will be changed externally. Very dangerous, but very easy to use. I was hoping to avoid that with a shallow copy, but, well, things complain. Amber Common is okay now, or should be. Redefinition of formal parameter data. Okay. What should we call it then? Current data. Can't duplicate certain things in C. Oh, I see. It was complaining about that, wasn't it? So all we've done is redefine that. So it boils down to that. Is that worth having? Is that worth having as a function? The answer is no. Why not just do that? What happens if we want to change the way integers are used in our main program? Or by our system, our UDP system. And this changes to something else, this line. We would then have to go through all of the instances of this call within the client and the server and change them all. Or we can leave this in here and just change whatever we want in here. And that will then update the rest of the program. As ITOA could be used quite a bit. Because there is going to be an ATOI, but that's going to be handled differently. I'm going to write my own. You'll see what I mean when we do that. So extract integer from data is going to be a little piece that I like, that's different. Are we happy yet? I am. I'm a lot happier than I was at the start. I'm glad we've been able to boil it down to the simplest function ever. I'm more than happy that that will work. Okay, how's our client doing? Wait a minute. How is our client acting now? No warnings, no errors. Ooh, interesting. Does it work though? We're getting complicated now, aren't we? We've removed another bit of weird text, and now we have a simple to read text. But we've also done something else. We've made a solution, a very simple one at this point in time, but we do have a solution. So we have our data. We want to add 1, 2, 3, 4, 5. Then we want to add a delimiter. Oh God, that looks awful. Then we've got our variable length. So everything that we've changed now in the client has also been updated into the server. So we'll have to do a rebuild on you. 0 warnings, 0 errors. Does it work? Any reason not to? Well, plenty of reasons not to. If you can't find header files and stuff, we're right up the creek. Alright. Final test. Sometimes you'll find this, that what you're actually doing is you're just rewriting what a function is called. But there's a bigger reason for doing it, and that will be shown later on. This is the simplest way I can show you of why I have a game lib. Let's try it out. One game lib. Okay, here we go. Please work. No, I shouldn't say it like that, should I? It did. Worked perfectly. We've done it. We have cracked the problems. Bit by bit, step by step, what we've found out is that the C way of doing things, although it's a stupidly named thing, works. Cool. So we have updated our game lib to add integers. Not a massive update, agreed. But it's enough. As you can see, enough work went into it for the testing and everything to make sure that you're doing the right thing. So what have we got? GameLib. Updated to add integers to our data. Cool, huh? We can now add integers willy-nilly anytime we want to our data without the problems of shallow copies which corrupt your stack, or deep copies which really we don't need to use. That's complex and not, then you have to wipe. No, not going that far. What you do there is you set up a variable of memory, a block of memory. You deep copy everything into that block of memory, and then on the other side you deep copy it all out of that block of memory. That is not the way to do it. Okay, you might think that's a waste of a function. Just you wait. We are striking the surface, but we now have part of the solution. That can go away. That can go away. This is now correct. Right, have I written it downwards? Yeah. So that is now part of our files. How would you add more than one integer? Manual pointer arithmetic. How would I do more than one integer? For next loop? A while loop? Yeah. For next loop. I could copy a set of integers out of a storage into our data on a simple for next loop using an index, and index them through here, one at a time. So you've got 1,000 items, 1,000 integers to add to your data. You just have a for loop for 1,000 times and just execute that for info index for your for loop. Very simple to use. Don't need to, it does it for you. ITOA is a standard library function that does everything for you. We've tested it all the way through to make sure that it's not adding things or subtracting things from our data. It was initially adding things all over the place to our data, but we sorted all of that out and we made sure that only the delimiter can be added on a string cat, and only the data that we send through, that's this bit, gets added to our data. So we've tested all of that out. What are we on? What's going on here? Solution, come back to me. MMO experiment. Research. We'll have a look at research, can we? So all of these tests here that we've been doing, like base working code, variable length data, integer to ASCII, and now we've got the game lib update. All of these, you can see the little word tested on the end of quite a few of these. Sometimes I put tested, sometimes I put working. If it's working, that's fine. It means usually that I've got something in the back of my mind that says, we might break this. But tested means working fully. So server and client test for the library. So we test out the library, then we test out some base working code, and we knocked our head against the wall a bit to make sure that we get roughly to the right place, which is fine. And I just put that through. Damn. Not to worry. Alright, is there anything else I want to change before I that? Because that 10 is a magic number, I'm just putting a note on it, because I'll never remember. That's the bit that we can now ignore. We might change everything over to hex one day. Trust me, we might, to make things cleaner, more efficient, and means we can go then from 0 to 255 or 254 instead of up to 126, which is what we've got at the moment. But as we're using only ones and zeros in our data, it doesn't matter because we're using ASCII. So we're using ASCII data. And it's actually just sending the ASCII codes for each character across to the server. We've actually got quite far, further than I intended today. I was expecting to spend a lot more time working on the server and making a test server, but I think we're going to do that next time. It all looks so simple, and you might have a lot of questions saying, but how does it know how to do this? We tested it out. It doesn't go step past the boundaries. If it does, we get an error. We've made sure we get errors, and you've seen them, I hope. And it's been tested out, so I'm confident now that we have a set of working test programs and a set of working data programs. This conversion thing is going to go a lot further. This is going to become quite a big file with different types of conversions in it. That's just a simple, easy one to start off with. But I wanted to show you how to boil it down, what you can look at, the different types of way you could do it. But this way, we're not going to cause any problems. Which is lucky, I think. I think we've been very lucky with that today. I'm very happy with the results. We are going to be taking our local server and our local game lib and porting that over to Linux. We now have a server to place it on. I made that this morning. Everything's okay in there. Everything's okay in there. So we do now have our putty here, where I can put in 192.168.0.100. I can open. I switched it off, so I can't open it. We can access through there, and we are going to be... did I put FileZilla on? Yeah, we've got FileZilla. Good. So we can transfer our base code over. You're thinking, hold on a minute, you're going to put Windows stuff on Linux? Oh yeah, I certainly am. And that's next week. That's going to take some doing, actually, because I can't remember how to do half the things in Linux. But we'll go through it and we'll find out. We'll read the manual. Yay. In the meantime, if you're coding, try things. Try doing things in any direction, any way you wish, any way you would like to. I think last week's stream was the one where I was hitting my head against the brick wall, and I basically wasn't grasping the fundamentals properly. I'm getting back into it now. This is week 3. I'm starting to remember how to do things, and chat's been very good and very helpful. Certain things I still haven't remembered. But in the meantime, I would like to thank you all and catch you next week for programming, or Tuesday for EVE Online. Take care. Have fun.